When a load is connected to the generator, armature current flows. It produces armature flux. Armature flux combines with the main flux to produce the resultant flux. The resultant flux decreases or increases depending on the type of load. Since the terminal voltage is proportional to the rate of change of the resultant flux, it also decreases or increases. The voltage drop in the synchronous generator is due to the armature reaction, the leakage reactance, and the internal resistance of the stator winding. In case the leakage reactance and the internal resistance of the winding are neglected, then induced EMF is proportional to the main flux and the terminal voltage is proportional to the resultant flux. It appears that the flux is flowing through the coil, but unlike the current, it never flows. We say that it is linking the coil. When the flux rotates, there is a change of flux linking the coil. EMF is induced as per Faraday's law of electromagnetic induction. We have considered the top conductor only throughout our discussion. Flux linking the top coil is zero, but the rate of change of the flux is maximum. Hence, maximum EMF is induced in the coil. Applying Fleming's right-hand rule, direction of the EMF is outward. In case of a pure inductive load, the current lags the voltage by 90 degrees. Hence, maximum current is obtained in the top conductor when the poles are rotated ahead by 90 degrees. The direction of the armature flux is given by right-hand thumb rule. The armature flux combines with the main flux to obtain the resultant flux. Resultant flux is less than the main flux. Combined inductive and resistive load is connected to the generator. The current lags the voltage. Current becomes maximum in the top conductor when poles are ahead of the top conductor. The resultant flux decreases. Pure resistive load is connected to the generator. Maximum current is obtained in the top conductor when the poles are ahead of the top conductor. The resultant flux is less than the main flux. In case of resistive load also, poles are to be kept ahead to obtain maximum current in the top conductor. This is due to the reason that maximum current is induced when the resultant flux and not the main flux faces the top conductor. In case of combined capacitive and resistive load, resultant flux increases. In case of a pure capacitive load, resultant flux increases. The effect of armature flux on the main flux is called armature reaction. When the load changes from inductive to capacitive, resultant flux increases. Since terminal voltage is proportional to the rate of change of resultant flux, it also increases. In most of the cases, main flux is ahead of resultant flux. In case of pure inductive and capacitive load, these fluxes are in phase. Terminal voltage is less than induced EMF in the case of inductive load and more in the case of a capacitive load.